So then I said, in this analysis, we are having something called production functions. As I mentioned previously, we are going to study the behavior of the producers, who are the social beings. Right? They are also social animals. Therefore, we are going to see how the producers are making their decisions using some mathematical models. This is why it is called a production function. Therefore, production function provides us the technical relationship between inputs and output. Right? Production, it is taking inputs and making some output. Therefore, production functions provide some mathematical or technical relationship between inputs and output. If we are taking inputs, how much of output we are going to get, which is given technically. And when we solve that, that yields, though, that provide us the maximum output with the given inputs. So we have some technical relationship where it's kind of a function, mathematical function, where if the inputs are given, we will get what is the output. However, remember, production functions will not be giving profit maximizing output level. We can get it. Using the help of production functions, we are going to decide what is the profit maximizing output level. Right? If I am the manager, I need to decide how much to be produced. That will be decided by with the help of production function. But production function itself will not be giving any level of profit maximizing output level. Also not the cost minimizing output level. So I will be discussing these later, profit maximizing and cost minimization, because that is the two ways of getting our profit maximizing. But anyway, production function will not be giving these two. Then we can define a production function like this. Output is a function of capital, land, labor, and entrepreneurship. What are these? KLNE, or capital, land, labor, and entrepreneurship. What are those? Those are the production factors. We learned. So we have a technical relationship between inputs and output. These inputs are the production factors. Land, labor, capital, and entrepreneurship. They are the production factors. So in the production theory, what we are going to do, we are going to mix these and get some output. It says function. Q is a function of KLNE. So output is a function of capital, labor, land, and entrepreneurship. This simply tells us level of output. If you are worrying about this level of output Q, that depends on the change of capital, land, labor, and entrepreneurship. We can change the mix of these production factors, the way we are going to mix these production factors, and then we can get certain level of output. That is given with the production functions. Now, as we are doing in economics in many places, we can assume there will be only two production factors. Even though we learn there are 4 production factors, we assume that there will be only 2 production factors called capital and labor. Why we do that? Any idea why we are having only 2 production factors? It is because of easy graphing. Otherwise, you can put all 4. But easy calculations and graphing, we are using only 2 factors of production, capital and labor. But these 2, capital and labor, includes everything. We can put both land and capital together. Land and capital together and call capital. Right? Land and capital together, we call capital. And labor and entrepreneurship together, we can call labor. So we have the involvement of the human with labor and entrepreneurship, and the involvement of natural environment and the financial environment with capital, right? If you want. But simply why we are doing that, just for two-dimensional graphic. So when you work with the algebra, of course, you can later relax this and increase the number of production factors. And in fact, we do that, not in your level, but in the management faculty, these ENM students, they are estimating the demand functions using several variables. For you, this is enough. We assume that there will be only two production factors, capital and labor. If it is the case, we can give it like this. So this is the technical relationship. And this is the functional form. Right? It says output is a function of capital and labor, and functional form will be something like 2 multiplied by K power to 0.5 and L power to 0.5. This is an example for a production function. I will explain this later, but this is an example for the production function. So then, even though we look at here, the functional form, this functional form is known as Cobb-Douglas type of production functions. Right? Cobb-Douglas production function, so Cobb-Douglas type of production functions. If we are having a Cobb-Douglas type of a production function, we are having the generic form like this. Q equal to A times K alpha L beta. Right? So K and L already known, and Q also known. Q is for output, K stands for capital, and L stands for labor. Because we assume that we are having only capital and labor in this world. If we are having only capital and labor, then we can put this capital and labor into the production function and get the return. And there are two types of parameters. This A, that stands for efficiency parameter. How efficient? I will show you that with the calculations. Or simply it tells if you are mixing certain amount of capital and labor together, what is the expected return? Is it the same as the size of the capital and labor? Or with the amount of capital and labor? Or is it more than that or less than that? And that depends on the efficiency parameter. In this equation, efficiency parameter is here. This one. This A tells us the efficiency. How efficient your mix of land, labor, capital, and entrepreneurship and getting something as output. And this alpha and beta stands for allocation. We call them allocative parameters. How we are going to allocate, how much of capital, how much of labor. Maybe we want to put more labor, which is called labor intensive. So then beta value will be a bit higher compared to alpha value. So I have put an example here. Efficiency is 100, which says if you mix one labor, one capital, your output will be 100 because it is the efficiency parameter. And alpha value 0.5 and beta value 0.5, which says you are going to mix equally, equal amount of capital and labor in this production process, which is given by 0.5. Both are the same and it is 0.5. Using this information, we can generate this production function. So output is a function of capital and labor, where efficiency is 100 and allocative parameters are 0.5. So this is providing us the mathematical relationship or technical relationship. Using the several amounts of capital and labor, we can have different levels of output. So here, what I have done, using this equation, 100 times K 0.5, L 0.5, I have calculated this production outcome. So this is the Q. If we mix one capital, one labor, my output will be 100. One capital, one labor, output will be 100. Likewise, we can mix 2 capital and 1 labor. So then output will be 141. Likewise, we can put 1 labor and capital 8. Then 283 as our output. Likewise, we can have different combinations. This production table provides us all the information about different combinations of capital and labor, and what are we going to get as the output. Now, if you look at this table, what you can say? We can say several things with this table. What can you say? Can someone say anything? There are certain points we can identify which are belongs to this production function. There's a question, what is the purpose of this 0.5? That tells how much of capital we are going to mix. Out of K, power to 0.5 will be employed. With L also power to 0.5 will be employed. Instead of 0.5, let's say this is 0.2. What do you think? What are we going to do? We are going to put more capital. Capital is power to 0.5 and power to 0.2, which is we are going to put more capital and less labor. That is why we put 0.5. So 0.5 is known as allocative parameter. Allocative. How much we are going to allocate. How we are going to do our allocation. How much of K, how much of L. That is given by the value of alpha. Okay, by looking at the table, suggest me few points which you can see. If you look at the, okay, we have one. Yes. If you look at the table, the simple answer, you see that 245 is marked in red. So if you just understand the table, I hope you can understand the table. Right? So we have 1 labor, 1 capital. That tells us how we are going to mix labor and capital. You can put this one here and this one here and do the calculations and you get 100. So that tells simply us, if you are mixing 1 capital and 1 labor, what is the level of output? So here it says 1 labor and 2 capital. Then what is the output level? It is 141. Likewise, any point in this table, any cell, tells us the respective output level. By combining this and this, like this final one, 8 labor and 8 capital, we will be getting 800 as the level of output. Then, if you look at this table, at once you will notice that I have marked red with 245. With that, the first point I can highlight, if I were asked like you, what I will say, I say 245 in different places. I put in red mark, in fact, because of that. And I have different combinations of labor and capital which yields the same output level. You see, here 6 labor and 1 capital. 6 labor and 1 capital, it is 245. 3 labor and 2 capital, 245 as the output. 2 labor and 3 capital, 245. 1 labor and 6 capital, 245. So that tells us we can mix different levels of capital and labor and get the same level of output. To get the same level of output, we can have different levels of capital and labor. One important thing that we can get from this table. The other one, this one we will be taking seriously, and the other one, if you look at this diagonal, you see 1, 100, 2, 200, 3, 300. Right? When you increase your output, when you increase your inputs, with a certain proportionate, your output will be getting into different values. And those different values are, in this case, only in this case, getting into double, right? If we double our inputs, we had one labor, one capital, we double it. We put 100% increment. Then we increase 1 by 1 to 2, and here 1 by 1 to 2. So then it will become 200. So output doubled. And we had 2 capital. Let's say we are going to put it by 100%. We put another 2, right? It will be 4. And here 2, and we will be putting that also to 4. So then 4 labor and 4 capital we will yield 400. It is again double. Previously it was 200. So that tells, if you look at this table, we can see that when we change our input with a certain proportion, output will be increasing with the same. There's a special reason, because this is 0 plus 5, 0.5 plus 0.5 equal to 1. So that is the reason why we are having almost double. But later we will discuss that part. But in this graph, you may understand that we can get that. And we will get the same amount of output with the different levels of input. And if you look further, you will be noticing several, like this one and this one the same. 2 labor and 1 capital, 1 labor and 2 capital, still we are getting the same amounts, right? So likewise, we can find several other places, but let's start with this one. Equal output with different combinations of inputs, which can be shown like this. And we are having 4 combinations. Let's assume A, B, C, D. So capital will be 6, labor will be 1. Output will be 245. And in the D combination, capital will be 1 and labor will be 6. Output will be 245. This tells us, in the production process, we can combine resources and we can alter the combinations. We call substitutability. Substitute. We can substitute something for something else. We have certain amount of capital, certain amount of labor. Then instead of labor, what we can do, we can give up some capital and put that in the labor. Still we are getting the same amount of output. So this is called substitutability. Substitutability means we can substitute one thing for the other. But our output will be still the same. Right? Then, depending on the amount of capital and labor we are employing, we can say whether we are using capital intensive production process or labor intensive production process. If you are using more capital, like combination of A having more capital and less labor, output is 245, we say it is capital intensive. We are using more capital in the production process. So it is capital intensive. And if you take a point like D, combination of D, then 1 capital and 6 labor. We are using more labor. Then we say we are labor intensive. We are getting the same output level, but using more labor. If we are using more capital, we say capital intensive. If we are using more labor, then we tell labor intensive, which is given in this graph. Efficiency parameter, how to decide the value of the efficiency parameter, that for that we can use regression. Right? Simply, if you are taking a Cobb-Douglas type of a production function, what we can do, we can put them into log. Right? Then we can have some survey and get these log values and put that into the regression. If you run the regression will generate the regression output, in which the intercept is the efficiency parameter and alpha values. or coefficients will be the alpha and beta values. So if you like, we can calculate later to get the efficiency parameter. Okay, with that, I would like to finish for today.